Hi, Mr. B here. Today I would like to demonstrate how to use the combined gas law to solve for an unknown temperature, pressure, or volume of a particular gas. If you live in the New York area, then you're familiar with the New York State chemistry reference tables. On table T, we find a formula for the combined gas law. P1 V1 over T1 is equal to P2 V2 over T2. But for most students, this formula is much easier to use if you simplify it. T2 P1 V1 is equal to T1 P2 V2. Okay, great. Now let's apply this formula to a specific problem. If I have 17 liters of a gas at a temperature of 67 degrees Celsius and a pressure of 88.89 atmospheres, what will be the pressure of the gas if I raise the temperature to 94 degrees Celsius and decrease the volume to 12 liters? Okay, this problem is very easily solved using the combined gas law. This is how you do it. Okay, so after reading the problem, we should pick out the given and the unknowns. In the problem, we're given 17 liters of gas initially. We're given an initial temperature of 67 degrees Celsius. We're given an initial pressure of 88.89 atmospheres. Then the temperature changes to 94 degrees Celsius and the volume changes to 12 liters. Okay? So in this case, our unknown is our P2. Okay? Now, what you have to remember about gas law problems in general, you cannot solve a gas law problem by using the Celsius scale. So therefore, our temperatures must be converted to another scale known as the Kelvin scale. Converting to Kelvin is very simple. You simply add 273 to each Celsius temperature. So now my T1 becomes 340 K. My T2 becomes 367 K. All right? Very simple calculation. Okay? Now we can modify our givens to reflect our converted temperatures, where our T1 is 340 K and our T2 is 367 K. Now it's time to solve. So at this point, we simply apply the givens directly to the formula. So, my V1 is 17 liters. My T1, which is on the other side of the equal sign in this case, is 340 K. My P1 is 88.89 ATM. My T2 is 367K. And my V2 is 12 liters. And of course, P2 is my unknown. Okay? Now I'm going to arrange this calculation into something called a final numerical setup. I'll just use a different color pen for this process. P2 equals 88.89 times 17 divided by 12 times 367 divided by 340. This is called a final numerical setup. Okay? Now, to solve for the problem, we simply do the calculations in parentheses first. So P2 is equal to 1.417 times 1.079 times my 88.89. Okay? And when we multiply 1.417 times 1.079 times 88.89, our final answer is 135.9, and our units, of course, will be ATM. Okay? It's as simple as that. Hopefully, this will help you out in the future when you're trying to solve for gas law problems, especially those problems that include temperature, pressure, and volume. Once again, this is called the combined gas law. Okay, great. See you later.